Hey everyone! Ever wondered how AI is getting better at solving complex problems, like math equations or coding challenges, without just memorizing answers? Let's dive into the latest breakthroughs in large language models, LLMs, and how they're becoming smarter step by step. At the heart of this progress is chain-of-thought reasoning, a technique that mimics how humans break down problems into logical steps. Imagine a student thinking, first I need to, then I should. This method, paired with advanced neural networks, has unlocked capabilities that go beyond pattern recognition. But here's the twist. These models aren't just thinking, they're learning from synthetic data, a carefully crafted dataset of fake but realistic problems and solutions. It's like giving a student thousands of practice exams, but tailored to push their reasoning skills. Researchers generate massive synthetic datasets to train models on tasks like coding, math, and theorem proving. But how do they ensure the model actually learns? Enter reinforcement learning, a system where the model earns rewards for correct answers and adjusts its approach when it's wrong. This feedback loop, combined with synthetic data, creates models that solve problems with surprising accuracy, even when the answers aren't obvious. Now here's where it gets really cool. Some models now integrate code interpreters, allowing them to execute and debug code in real time. Others use verification systems to catch errors, like a teacher grading a student's work. These tools bridge the gap between natural language and precise computation, enabling models to tackle tasks that once seemed impossible. Take DeepSeek-Prover, which uses synthetic data to train models in theorem proving. Or rStar-Math, which teaches smaller models to think deeply about math problems through clever data generation. And there's Retool, which optimizes how models use tools strategically, like a chef choosing the right ingredient for a recipe. But it's not just about raw power. Researchers are also focusing on efficiency. Some models use reinforcement learning to minimize unnecessary steps, while others prioritize tool integration to make problem-solving faster and more reliable. It's like teaching a robot to not only solve a puzzle, but also figure out which tools to use along the way. The future of AI isn't just about bigger models, it's about smarter ones. By blending human-like reasoning, synthetic data, and real-world tools, these systems are tackling challenges that once seemed impossible. With techniques like co-RT and hint engineering, we're seeing AI that doesn't just think, it thinks with code. Ever wonder how AI is getting so good at solving tough math problems without needing a mountain of data? Today, we're unpacking a study that's rewriting the rules of machine learning. It's all about making AI smarter and more efficient. Let's dive in. Here's the big idea. Instead of feeding AI thousands of examples, researchers gave their model just 30 high-quality examples, hand-picked by humans. Think of it as teaching a kid to solve complex math problems by showing them expert solutions, not endless practice tests. But how does that work? The secret sauce? Refinement through feedback, RFT, and reinforcement learning. RFT acts like a smart editor, refining the AI's answers, while reinforcement learning functions like a reward system. Think of it as training a dog with treats for correct answers. Together, they teach the AI to think strategically, not just memorize. Now let's talk experiments. The team tested models ranging from massive 32B parameter giants to a sleek 1.5B version. Surprisingly, the smaller model crushed tough math challenges. How? By distilling knowledge from larger models and fine-tuning, with just 10,000 carefully selected examples. It's like learning from the best without the clutter. But here's the twist, they focused on hard problems. They built a training set of 1,000 challenging queries, forcing the AI to grapple with tricky questions. This hard query approach might take longer to train, but it pays off. Models trained this way perform better in the long run. It's like practicing with the toughest puzzles instead of the simplest ones. And there's more. When the AI wrote Python code to solve problems, the researchers noticed something cool. The best-performing models used fewer, more precise code snippets rather than churning out tons of code. It's like a chef using just the right ingredients, instead of throwing everything in a pot. So what does this mean? This approach could make AI more accessible for complex tasks. Think scientific research, coding, or even personalized education. The takeaway: efficiency and performance aren't enemies, they're partners. By thinking smarter, not harder, AI is breaking barriers. Thanks for watching. If you want to see how these techniques work in action, hit that like button and subscribe for more deep dives into the future of AI. Until next time, keep questioning, keep learning.